Hello everyone, welcome to this video, and today in this video it's about graphs of motion, and this is a grade 9 topic, grade 9 physics topic that I'm going to take. In this video I'm going to give you a complete overview what are the graphs of motion and why are they important for us to study. And I'll be discussing about few types of graph and the very slight differences that are between them. And in order to understand that difference, I'm going to give you a real life example, a real life situation, and I'm going to form the graphs of motion for that, and you will be seeing that how a real life situation example can be created in a graph of motion and in different graphs. Right. So this is a part 1. This is only a part 1 of graphs of motion. If you want part 2, you have to tell me in the comment section that you want the part 2 of this graph of motion also. And yeah, a very important thing, at the description of this video there is a poll that I have kept, and in that poll you can select if you want the continuation of this graphs of motion or you want to have another topic. So with that, let us get into the concept. So now let me screen share, and talking about the graphs of motion, there are two graphs of motion. When I talk about graphs of motion, there are two types of graph. One is known as the distance time graph, right? And there is a variant for distance time graph. There is something very look alike of distance time graph, and that is called as a displacement time graph. Now let me tell you, they both are not same. There is a slight difference between them, a very slight difference between them. That is what you are going to understand now. Then you have speed time graph and another variant of speed time graph which is known as velocity time graph. You have velocity time graph. Now, as I told you, these two graphs, speed time graph and velocity time graph, they appear very similar, but they are not similar. There is a slight difference between them. So first, what you need to understand here is that these are the types of graph. Now, as I told you, you will understand this graph with an example, with a real live example, which will make you understand the whole concept very clearly. Let me take you to a situation, and that situation is, this is my real life situation. First, let me work with my DT graphs, that is distance time graph or my displacement time graph. So I am going to work on this displacement time graph. So this is my first discussion. So for this graph, I will give one situation. First I will make a distance time graph for it, then I will make a displacement time graph for it. First let me begin with my distance time graph, and the situation is this. A man starts from his home, okay, starts from his home, okay, starts from his home, goes to, okay, he goes to a shop which is somewhere around, I would say 500 meters away from the home, okay. So he starts from home and he goes to a shop which is 500 meters away, okay. Then he stays at the shop for 1 hour. Yeah, I will give the time also. Going this 500 meters also took 1 hour for him, okay. Going 500 meters also took 1 hour for him, and he stayed there for not 1 hour, let's make 2 hours, let's make it 2 hours. He stayed there for 2 hours, okay. After staying there for 2 hours, he starts his journey back. Okay, he starts his journey back, and while coming back from the shop 250 meters, so when he is starting from the shop 250 meters, so when he has walked 250 meters from the shop, right, 250 meters from the shop, he meets his friend. Okay, so to reach this 250 meter, he again took 1 hour. This time he was very slow. Okay, he took 1 hour. Okay, and he talks to his friends. Okay, he talks to his friends, talks for 30 minutes. Let's take it as 30 minutes. And then from there, from the point where he met his friend, he comes back home. Okay, he comes back home in next 30 minutes. Okay, he talks for 30 minutes and he comes back home in next 30 minutes. This is his journey. Okay, understand the journey completely. Once you understand the journey, that is when you are going to plot the graph properly. So in his journey, he starts from home, goes to a shop which is 500 meters away, and he takes 1 hour to reach the shop. He does the shopping for 2 hours. Then he starts his journey back, and he comes back in 250 meter. He meets his friend. So to reach that 250 meter, he took 1 hour. He talks to his friend for 30 minutes, and after talking to his friend, he comes back home. The remaining distance he covers in next 30 minutes. Right? Now you understood this particular journey. It's a very simple journey. It's not a very complex journey. It's a very simple journey. Now you are going to draw a graph for this, a distance time graph and a displacement graph also. A distance time graph you are drawing and a displacement time graph you are drawing. First of all, let me make a distance time graph. So distance time graph, the y-axis is the distance. My y-axis is the distance and my x-axis is the time, which is a very fundamental thing to remember. In a distance time graph, this is my distance. My y-axis would be my distance and my x-axis would be time. That's the reason why I say that time is an independent variable. Time is an independent variable and distance is my dependent variable. That's why it is, you learn that your dependent variable should come in the y-axis and your independent variable should come in the x-axis. Okay, now look at my journey. What is the total journey time? 1 hour, 2 hour, 3 hour, 3 and 4 hours. So 30 plus 30, 1 hour, right? So my total journey time here is totally 4 hours. So I can make the time, okay, I can give the time axis 1 hour, 2 hour, 3 hour and 4 hour. So first what you need to do, or what you need to give, is the axis. Then you have to give the distance axis. So 500 meter. Then he comes back in a then he goes 500 meter and comes back 500 meter. So I would give it in meters, 100 meters. So the total journey is basically 1000 meters. So he has covered a total journey of 1000 meter. Why? 500 that side, 500 back side, 500 to the shop, 500 backward. Yeah, of course he stayed in between, but that doesn't matter. What is his total distance, total path covered? His total path covered is basically 1000 meter, which is 1 kilometer. I cannot give kilometer, so I give in meter in the axis. 100, 200, 300, 400, 500, 600, then I have 700 here, I have 800, 900, 1000. So I have given my distance axis, I have given my displacement axis. Second step, I need to put the data point. So my first data point is going to be the origin. Yes or no? It's going to be origin, right? Why? Because he's starting from home at 0 time. The next data point, that he has reached 500 meter in 1 hour, which is here. The next, he stays in 500 meter itself for next 2 hours. Yes or no? He stays in 500 meter, that is the shop. He stays in the shop for next 2 hours. So in third hour, his distance is same, 500 meter. It has not changed. Now he comes back. Okay, all right, you require more time here. Okay, 30 minutes. Yeah, no, okay, it's 30 minutes, fine, it will do. Now from there he comes in 30 minutes. Okay, in 1 hour he reaches back. So actually you see here the time is more here, 1, 2, 4 hour, 4 and 5 hour. You require 5 hour for this. You require a 5 hour axis for this, students. Okay, you require 4 and 5 hour. Fifth hour is also required here. Okay, so in third hour he is in the shop. Now he begins his journey. In the next 1 hour he travels more 250 meter. In next 1 hour he travels more 250 meter. I would say that in fourth hour he has reached a distance of 750, because 500 plus 250, it is 750. So in the fourth hour he is in 750. Okay, then he stays in 750 for 30 minutes. So half of that, he stays there for 30 minutes, and in the next half an hour he travels more 250. That means he completes his 1000 meter distance in the fifth hour. I got my data points here. Okay, I got my data points. Now what will I do? I just join the lines. I join the lines here. Look here. Line number 1, line number 2. Okay, this should be actually exactly the same here. Line number 3, line number 4, line number 5. Now students, this is your distance time graph. Okay, this is your distance time graph for this particular journey. This is your distance time graph for this journey. And look here, you should be knowing that a flat line in a distance time graph means at rest. So there has been 2 flat lines. One is at the shop for 2 hours. Other is for 30 minutes when he was talking to his friend. The remaining time he was only traveling. The sloped line represents that he has been traveling. Okay, and the slope, the steepness of these lines gives speed. So in mathematical terms, I would say that slope of these lines are giving you the speed. So look here, he has traveled 500 meter in 1 hour, but here he has traveled 250 meter in 1 hour. Look at the journey, students. 500 meter in 1 hour, 250 meter in 1 hour. So it is very much evident that he has been slower here. He has been slower here. Okay, that is why the slope of that line is not so steep. The slope of that line is lesser. Okay, this is the distance time graph for you. So I'll write it here. Slope of distance time graph is speed. Slope of a distance time graph is speed. Now let me make a displacement time graph now. Okay, let me make a displacement time graph for this. Now displacement time graph is going to be very much similar. Again, I need the points. Now I will draw that here. Let's decide the points that need to be given in this case. Okay, I have two axes. As usual, y-axis is my displacement now. It was distance in the previous case. Now this is the y-axis is your displacement. Why? Because now I am making a displacement time graph, and this is your time. Again, time is your independent variable and displacement is your dependent variable. Now let me come back to my journey. Okay, let me come back to my journey. Now again, in this journey also, the total time is going to be 5 hours only. The total time is going to be 5 hours. There is no change in that. The total time is going to be 5 hours because time is non-directional. Time just keeps on going. So you have 0, 1, you have 2, you have 3, you have 4, you have 5. So there is no problem in that. But displacement, I need to be careful. See, in my journey, my maximum displacement is 500. See, I start from 0, I go till 500, then I'm coming back, right? So what is my maximum displacement value? Because my final displacement is going to be obviously 0 because I'm starting from home, I'm coming back to home, so my final displacement is going to be 0. But what is my maximum displacement? Because I should know my maximum displacement because I want to plot the graph. So for the graph, I need to know the maximum value of displacement, and clearly it is said here that the maximum displacement of this person is 500. So I need not draw a axis more than 500 meter. Understood? I need not draw. See, once you understand the difference between distance and displacement, you will know that the maximum possible displacement is only 500, but for distance it is 1000. 500 this side, 500 back side. That's why I wrote 1000 for distance graph, but here I would do my job with only 500, 100, 200, 300, I have 400 here, and I have 500 here. Now let us start the journey again. So at 0 time, I am at 0 point origin. Now it takes 1 hour for me to reach 500. Yes, very much similar to my distance time graph. Stays in the shop for next 2 hours. Very much similar. Now this is where the game changes. He comes back 250 in 1 hour. That means in the next 1 hour he is somewhere back. His displacement has become 250 again. His displacement has become 250 again, because why? He has gone, then his displacement was 500, he comes back 250, he comes back 250, so his displacement is 250. So that's why in 4th hour his displacement is 250. In the 4th hour he talks with that person for 30 minutes. So for the next half an hour the displacement remains 250. And the remaining 250 he comes in the next half an hour, which is at the 5th hour he comes back to 0. His displacement becomes 0 in the 5th hour because he reached back home. He has reached back home. Now I make the graph. So now look here. This is how my graph will look like. Which graph? Displacement graph. Join the points here, here, and here. Yes, this is how your displacement time graph for the same journey, now you look at the difference is very much clear here. You look at the distance time graph and you look at the displacement time graph, they both are different, but the journey is same. So this is a very much important difference between a distance time graph and a displacement time graph. Now I told you, for a distance time graph your slope is speed, and you look here, your slope cannot be negative. Your slope cannot be negative because speed cannot be negative. Speed cannot be negative. So that's why in the distance time graph your slopes are always positive slopes. It always keeps on going up. It always keeps on going up. It does not come down. But it is different here. You know why it is different? Because the slope of a displacement time graph gives you velocity. Okay, the slope of a displacement time graph, this is very, very important to understand. The slope of a displacement time graph gives velocity. Yes, it gives velocity. Velocity can be negative. Understood? Velocity is a vector quantity and velocity can be negative, and that is the reason why you are seeing a downward facing slope. Okay, look here, this is upward facing slope. Velocity is positive, velocity is 0. From here the downward facing slope starts. Why? Velocity is negative now because he is going in reverse direction. Remember, velocity negative means the object is traveling in reverse direction. Here also the velocity is negative, which literally means that he is coming back. Going is velocity forward, coming back is velocity reverse. Right? So this is the important difference. This is the important difference between a distance and a displacement time graph. Now students, if you want to know the difference between a velocity time graph and a speed time graph, that I can make for you in the next video, right? Now, as I told you, there is a poll section. If you want the continuation of this video, please select, and if you want the continuation of this particular video and if the polling wins for this continuation, I will be surely making a video which is a continuation of this, which is going to explain speed time and velocity time graphs difference, right? I want you all to join in polling and voice out your doubts, voice out the topics which are difficult, and I would try to make a video on that particular topic. So I believe I have helped you a little bit to understand the difference between a distance and displacement graph. So with that, we will end today's video. We will come with the other video for next class. So I will be taking class for 9th, I will be taking for 10th, I will be making videos for 11th and 12th, and I will try to solve most of the difficult concepts and make it very easy for you. So with that, I will end the video now. We will see you in the next video. Adios.